All right. So, hello, engineers. Welcome back to the last session or the sixth session of the ROS Learning Series. And today we are going to discuss ROS2. So, from in the previous sessions, we have been discussing how to use ROS and what are its concepts. Today we are going to discuss ROS2 and in more detail how it was developed, and we are also going to run one basic program in ROS2 as well. So let's do that. Okay, before starting, I would like to tell that I will also be hosting a session on Python for AI. It will be hosted on this Friday, April 22nd. Not on this platform, on a new separate platform called Lighthall. Lighthall is a new platform for educational streaming content, and this session is free of cost. In this session, you would be learning about what is AI, what are its different basic algorithms, and we will also be implementing an algorithm from scratch in Python. Along with that, I will also discuss basic commands of Python as well. So everything will be taught up from the scratch, and there are no prerequisites for attending this session. So if you like this series of sessions and you would like to attend this, you can go and register for this session. I will share the link in the Google Classroom as a post. You can also share it with people who would like to learn about Python and AI as well. So do share it as well. Okay, a bit of a recap before we move on to the session. We have been discussing ROS, and today our topic of discussion would be ROS2. Yes, today our topic of discussion would be ROS2. So let's start with it. Okay, now the development of ROS was actually inspired by this robot that we see over here, which is called the PR2 robot. Now, from the start, the creators of ROS knew that they want to create a software that will be useful on all the robots as such. But as a reference, they use the PR2 robot to build their system or software. Hence, ROS has acquired some of the properties that are on for this PR2 robot specifically. This PR2 robot actually consists of two robot arms, as we can see over here, and it also has a wheels on its base, and hence it can autonomously navigate through its environment, and it can even pick up and place objects and so on. So the properties that some of this robot had were that it is a single robot, and this is a single robot that needs to be controlled to move it around the environment. The second thing was that this robot does not have any real-time requirements. All the processing on this robot can be done on a laptop, on a separate laptop computer, which will be connected with this robot, and all the processing would be done on that laptop. No, not much processing would be done on the robot itself. Hence, there were no real-time requirements as to devices that we see today. For instance, drones, they need quite fast processing in order to work. And there are also other edge devices as well that require processing on board to speed things up. Another assumption we could say that they had was that they were testing everything in a lab. So the network characteristics that they had were completely perfect. There were no lags in the network. There were no hackers in the network. Everything was completely fine. So all these three characteristics, more as well, but these were the three main characteristics that are in this robot. And while developing the ROS software, that ROS software also has these properties as well. Now, in the real world, this is not obviously the case. This is not everything that we would see in the real world. In the real world, we would have multiple robots like the warehouse robots that need to coordinate with each other while moving so that they do not collide with each other. And we are also going to have real-time systems where processing power is limited and we need to do calculations faster as well. There would be non-ideal networks as well, like there could be hackers on the network, and there would also be lags or some other things in the network as well. Also, the ROS system also needs to be used on a production-based environment in places where there is no research or anything. We need to be fail-proof in these type of production environments. So all these four properties, additional four properties, people while using ROS, people did try to overcome these things that we had over here. Although people have come up with solutions while using ROS to overcome and do multiple robots make it work on real-time systems, make it work on non-ideal networks, and so on. But looking at all these problems, there was a need to come up with a new system, a completely architecturally different system. That's what had ROS2. So that's why ROS2 was developed, to deal with all these different issues that the developers of ROS learned after they developed the system, and that was used by different people. So that's how ROS2 came into picture. Okay, so now let us discuss some of the differences in the ROS1 and ROS2. The first difference is on the ROS API. We have been writing codes in the previous session as well, just very basic codes. And in that, you would have noticed that we were using different libraries. For Python, we were using this ROS.py, and for C++, we were using this ROS/ROS.h. For C++, the library name is ROS CPP, and for Python, it's ROS.py. Now, in terms of software architecture, both these ROS1 and ROS2 libraries were developed independently of each other. What this means that ROS1, the Python developers for the ROS1 library were different, and the C++ developers were completely different. So they worked on completely separate projects. What this means in software terms, that one feature that would be available, let's say in Python, would not be available in C++, because the teams would need to coordinate with each other in a slightly different way so that they can communicate all the information. So all the structure of this ROS.py code and all the structure of the ROS CPP code is going to be different, because it is independent, because it was independently created. In ROS2, they improved over this. In ROS2, they have a basic library called RCL, and RCL is a base library for the Python as well as the C++. For the Python, we have RCL.py, and for C++, we have RCL CPP. Now, both of these libraries come from the same parent library. Hence, there is more concurrency in both of these, and there are not many different changes. In software terms, it is also a good thing, because having consistent things is better than having completely two independent things that almost do the same task. So ROS2 is an improvement over this one. Next is ROS nodes, how we write the ROS nodes. Over here, we have this ROS1 sample file of Python where we are creating a node. Now, in ROS1, there was no restrictions as to how we can write our code. We can either use an object-oriented type of programming, or we can simply do the function type programming, as we can see over here. It was completely up to us how we wanted to create the different, create the code for the different nodes. However, in ROS2, it's a necessary thing to create object-oriented code. We are going to have a base class of node, and we are inheriting that base class to create new classes of the nodes that we want to create. So that is also a consistent thing that they have introduced in ROS2, so that all the code that is created for ROS2 is consistent everywhere, even in the packages that other people develop. So that's another change. In ROS1, the launch files were written in XML format. As we can see over here, there are different XML tags that we have to write to create the ROS1 code. In ROS2, these launch files are not written in XML, they are written in Python itself. Now, what this means, that we can introduce complex logics compared to the XML file. We can add if-else statement, we can add loops, so that the launch files are a bit more complex and they can launch the nodes in some fashion that they want. That's an improvement in ROS2. Okay, so the architectural different, the previous differences that we discussed were more on the code side. Now we have the architectural difference. In the previous sessions, we discussed that ROS works on the basis of a mathematical thing called ROS graph. In ROS graph, we had different nodes that did all the different processing, and these nodes were connected by edges that helped communicate with the nodes with each other. In ROS1, the ROS graph is handled by what is called a ROS master. This is a master node that is responsible for helping the different nodes communicating with each other, as we can see in the diagram over here as well. ROS master just tells another nodes like where the node is located, so the other nodes can communicate with each other. In ROS2, we do not have such a ROS master thing. All the nodes are completely independent. They can work separately and they can find the different nodes and communicate with each other without the need of a ROS master. What this means that ROS1 would be a more centralized kind of system where we need a master system. And in ROS2, it's a decentralized system. Every system can have a single node as such. Also, there is a difference in services and actions. Services and actions were also discussed in one of our previous sessions, that services are synchronous messages and actions are asynchronous messages. When we write a service to communicate with the nodes, ROS uses services and actions. So services were synchronous. The code that we wrote had to wait before an answer comes from the service part of server node. In actions, we do not have to wait for the query to solve. The node or the code can go on and execute itself while it is receiving feedback from the action server that we had. Another thing that was in ROS1, that actions were not a part of the ROS system when ROS was first developed. Once the different versions of ROS came up, actions were introduced later on to deal with the different things that the people wanted to do with ROS. So actions came a bit later in ROS1. In ROS2, we again have services and actions, but this time in ROS2, actions are pre-built in the system itself. And the services in ROS2 are actually asynchronous. So the code can keep on running and the server can later respond to the query that it had. Another difference is that you may remember that in the previous sessions, to see the different actions that were running, we did not have any command like ROS action list or so on. In ROS2, we have a dedicated command for that called ROS2 actions list to see the different actions, because the actions are actually architecturally embedded in the ROS2 system. So this is also an improvement in the ROS2 system. Okay, so these are the major changes that were in ROS2 coming from ROS1. The commands are a little bit different as well. We are going to see them in the demo itself as well. So, and the changes that we discussed, they are not completely all the changes that were in ROS1 to ROS2. There are other complicated changes as well in terms of software engineering terms, like what is the base software used and so on. But we do not need to delve into those details, as it would be more complex to explain and not required for us as also. So now we are going to jump into the demo and see how ROS2 differs compared to ROS1 in terms of the commands and all the things that we are going to run. So moving on, if anyone has any questions regarding what we discussed, they can ask. Okay, so no questions, so we will go on. Okay. Now, just like we did in ROS1 as well, first we installed ROS1 Docker container, Docker image, and then we ran the container. Same way, we have to first install ROS2 container so that we can run ROS2. Now, the command for that would be docker pull the command is listed over here, ROS2 desktop VNC Foxy. Now ROS2 has different versions as well. Like the current ROS2 version is the Galactic version, but over here we are using the Foxy version. It's only because I have used the Foxy version before, hence I'm using this for this session as well. Otherwise, you can try out the Galactic version as well if you want to. Once we press enter on this command, the container, the image, the Docker image will start installing, and we would have installed the image. Then it's the same steps that we had done previously as well, that we first need to run the Docker container. For that, the command is docker run -- name ROS tutorial, and all this command that we have over here. Once again, we have to run this command only once. From next time onwards, we only need to use the GUI application of the Docker that we can see over here. I have already run it, so I'm going to start from over here. since you would be running it for the first time, you would need to run that command. So I'll just start the ROS2 container and we will start with it. The instructions to run are still the same, that we need to navigate to 127.0.0.1:6080. And I have written all the commands on the slides. You can check them later as well. Okay. So over here, okay. So now the instructions that we are going to follow come from this repository from GitHub that goes by the name Chapulina Dolly. I have put the link over here in the slides as well. So just to give a brief information about this package or repository, that this is a robot that is just used to test ROS2. We can see in the GIFs over here that it's just a small robot in an environment, and we can, and the creators of this repository have created code in such a way that we can do follow person, that we can run a follow person code as well, that we are also going to run in this session. So, okay. Now, okay. So these are the instructions given over here as well that we have to follow. We just need to follow these instructions. I'm going to discuss them over here. So the first step is again that we have to first open the terminal, and then we have to create a workspace that we did in the ROS1 as well. To create that, first we need to navigate to desktop, and then we need to make directory. We can simply name it WS, standing for workspace. The command would be WS/src. It will create two folders. It will create the WS folder, and inside that folder, it will create the src directory. Once we have created that, we are going to navigate to the workspace in the src folder, and again going to git clone that like we had done previously. The link to cloning would be available over here. github.com chapulina-dolly.git. We're just going to clone it over here. Now, one thing that we need to take care of, that once we clone, we are going to have all these files in our repository in the src directory. We need to remove this Dolly ignition package. This is important, as the thing is that there are two simulators for ROS. One is Gazebo and the other one is Ignition. We are not going to use Ignition for this session as such. Hence, we need to remove this Dolly ignition package so that it does not create problem in the build processes as such. So we will just delete it. I have included the instructions also in the slides in case you do not forget about it. We have to remove this Dolly ignition folder. Okay. So once we have done that, right. So once we have done that, we need to go write this command sudo apt-get update. This will update the different repositories in the Ubuntu system. And after that, we need to type the specific command in the workspace directory, that is ROS-dep install -- from paths. I'll just type the command and then explain what it is. This command is also listed over here in the instructions that they have given, ROS-dep install -- from paths and so on. What this does, it will install the different dependencies that are related to this ROS project. It will automatically do that. But in order for this thing will give error if we had not run the sudo apt-get install, sudo apt-get update command. We need to first run this command and then only we can run this ROS-dep install command. Otherwise, it will give certain errors. Just need to keep that in mind. Once we have done that, then in the ROS ones as well, our next step was to do the catkin make. Over here, the catkin make command doesn't work. The command is changed to colcon build. colcon build. Yes, colcon build. And it once we run this command, it will build all the different packages that are in this project as such. You can ignore this teleop twist keyboard. I was experimenting with some things. So this will not appear. The actual output that you would see would be something like this: Dolly follow, Dolly gazebo, and Dolly itself. So once we have, okay. So once we have installed this, then the next thing to do is to source the workspace. In this container, there is a problem that that the original ROS2 workspace is not sourced as well. So the command to do that is this source /opt/ROS /foxy/setup.bash. We need to run this command in this system. It was not required in the ROS1 system as it was already done for us. In this image, it is not already done for us. So we need to do this every time we open a new terminal over here. So once we first do that, and then we have to do the same command that we did that of devel/setup.bash. Over here, it's install/setup.bash. One another command that we also need to run is source/usr/share/gazebo/setup.bash. It's to source the gazebo files as well, since they are also not sourced in this particular container. So once we have run these three commands, so then we can type the ROS launch command that we ran previously as well. Previously, the command was ROS launch. In this, the command is ROS2 launch. And the command that we're going to run is Dolly gazebo dolly.launch.py. Okay, we can simply run this command as such. Now, when we run this command first time, it's going to take some time to load all the things. After we have run it first time, then it won't take much time to load. So we need once when we are running it for the first time, we need to wait a little bit so that it opens up. So this is again the robot that we have. It's currently placed in an empty place. In the next part, we are going to run it in an environment-based kind of thing. The RWiz is also opened for us. As we can see, the RWiz is also the same in ROS2, and the gazebo simulation is also the same in ROS2. Now let's run other commands as well. First, we go to new tab, and then we would type the command ROS2 topics list. So the topic list, it's a singular word, ROS2 topic list. As we can see, we have the different topics that are listed over here. Previously, we had the command ROS topic list. Over here, we have the command ROS2 topic list. And we also have the ROS2 service list as well to see the different services that are running over here. As we can see, almost similar. And we also have the ROS2 action list as well in over here. Right now, it is not going to give any output because no action is running currently. If any action had been running, it would have given the different actions that were running. But right now, no actions are running. So these are the different commands that we have in ROS2, almost similar to ROS1. Okay, now once we have explored everything, now let's run the actual simulation that they have given over in the repository. Okay. This is just to run. It was not stopping by itself. That's why I run this command. You just sometimes it hangs like this, so you can run this as well if you want. Now let's run the actual thing that we were about to run. ROS2 launch. Dolly sitting. And we can also add this RWiz false so that the RWiz window does not open again and again, since we are not going to use that over here. Once again, this command is also going to take time when we run it for the first time. After first time, it's not going to take that much time. And again, this will be a little slow on my computer. On your computer, it will run a bit faster. Okay, while it's opening, if you have any questions, you can ask as well. So once it has opened, then we need to select this tool over here. That is the move tool. It's right next second to the cursor tool. Once we select this, then we can move the different models that are present over here. Now to actually run the follow person thing, the follow person thing is already running in this simulation. All we have to do is move this human model over here. Once we move it, the robot will start following it. Now the thing to take care of while doing this is that we have to not move the human too much. Otherwise, the robot will start following this pole that we have over here. So we are only going to slightly move this model to see the effects that we have. Okay, so the robot didn't move. We will just move it a bit forward. Hmm. Okay, so I'm not able to completely able to demonstrate what is going to happen over here. On your system, that what is going to happen once we move this robot model, this human model a little bit, the robot is going to start following this human as such. But right now it's not happening. Maybe it would be happening, but due to the system load, it's a bit slow over here. That's why it is not moving. You should try this on your system and you would see it running as such, as they have given in this GIF over here as well. That they move the robot, the human model, and the robot will just start following it. Something like this. Due to the load, it may not be working as such, so no problem. Okay, I will be closing it. So most of the demo was related to this repository, and we are done with the demo as such as well. The instructions are still the same, that you have to replicate all the things that we discussed in this session and put a video of that in a social media post. Another thing, that since this is the last session, I would also like to discuss what you should go on to the next thing after this session. Now, there are two things that you can try. Mostly you would need to do different projects so that you can enhance your understanding with ROS. The more projects you do, the better you will learn about the different things that are in ROS. You can either create your own project or you can try running the different robot simulations as such. I have written some examples over here that are good projects that are related to ROS. The first one is JDE Robot Robotics Academy. This is a software that it runs on ROS. How this runs is that the simulations are all on ROS, and in this software we have to write the code that is related to certain algorithm the robot is trying to do. Like we have like there are different exercises for following line, so we have to write code for follow line, and the simulation for that will be running in ROS. There is an exercise on obstacle avoidance. We would have to write code for obstacle avoidance, and in the simulation that thing will keep on happening as such. So it's a learning kind of tool that people use to learn robotics. Next one is behavior metrics. This is related to deep learning, like how to write, how to create neural networks that would complete a lap around a circuit. So this tool is related to that, to study that behavior as such. Follow Dolly is the same project that we discussed just now. Robot arm pick place, this is a pick and place kind of project that you can have a look at. And this is a real life robot project. It's one of the projects that I personally like very much, and you can also try it. You can also try creating real life robots as well, taking inspiration from this link that I have put over here. Second thing that you can try is you can try creating your own ROS packages, or you can contribute to the projects on GitHub. Some of the packages that I have listed over here: Frenet Frame. This is a motion planning ROS package based on the Frenet Frame algorithm. It's mostly for self-driving cars, so you can check this project out. Navigation 2 is the ROS2 navigation stack. In ROS1, we had the navigation stack. In ROS2, we have the navigation stack as well. That is called Navigation 2. You can check this out and also contribute to this project as well. Third is Move It. Move It is the same robot arm ROS package that you can try to contribute to as well. One another interesting thing that you can do after you have learned ROS2 is help port the ROS packages to ROS2. Now, since we know that ROS2 is currently in development and there are a lot of different ROS packages that are waiting to be converted, to be ported to ROS2. So this is a really good exercise that you can also do, that would also help build your resume, as you would be contributing to GitHub projects, and it will also help you learn as well, since this is a big task. This is a project that some people even take 2 or 3 months to do. So this is a big task that you can also do as well. I've also included some of the good resources that you can check out. First is the Construct YouTube channel. This is an amazing YouTube channel that you can check, that solely puts videos on ROS, on how to do different things on ROS. Second, you can check books on ROS by Lentin Joseph. This is a great author on ROS. You can also check this. There is one particular book that I have listed on third point. This is a book by O'Reilly Publications. You can check this out. This is really basic book that will help you know what are the different things that you can do in ROS. And if you're willing to spend some money as well, then you can also take up courses by the Construct. It's the same company that is working on this YouTube channel. They have paid courses and they are really good as well. There are some conferences as well that you can have a look. First is the ROSCon. This is the most prominent ROS conference there is on earth. You can check the different talks from this ROSCon conference. There is also a ROS Developers Day. This is a conference. This is a more like a hands-on kind of tutorial-based conference that is held by the Construct. So you can check this out as well, since there are a lot of different talks that you can see how people are doing the different things over there. So these are the two things that you can check out in these slides. These two are good slides, I think. And this is all for the session and all for the complete series as well. Thank you all for your time and hope you learned something new, and waiting for you all to create different new ROS packages and the ROS projects that you would be doing after learning from this session. So if you have any questions, you can ask. Otherwise, do register for this live class. And yeah, that's all. So if you have any questions, you can ask. Otherwise, we can close.
Hello, Sakshay.
Hello.
Yeah, this is a very good series that you have started. That we have learned a lot with this ROS, and still learning also. And
Yes.
today also I had asked you one query regarding that this one also, that mobile robot,
Mhm,
regarding that mobile robot.
mhm.
Hello.
Yes, yes. Mhm,
Yeah, it takes a lot of time for carrying out that simple that one project that you had shown, no, in a single session. That we are doing this for a lot of time actually. It takes
mhm.
about 3 to 4 days just for completing a particular session.
Okay.
Yeah, we are very
So yeah,
thankful for starting this series, RAW series. Thank you very much.
happy to know. I've also seen your posts on LinkedIn, so they are also really good. So I like that you are learning something new from this.
Yeah, thank you.
Thank you for attending us. So, okay, Debyasank asks, how about the courses available in Udacity like robotics, software engineering, or intro to self-driving car? These are good courses, but I feel that the price is a little bit high. Although these are really good courses, if you do them, you will learn actually a lot, and you would also build your project portfolio as well. Since the projects that they tell us to do, we usually put them on GitHub. So you would build your project portfolio as well. If you like, I'll just brief what they actually teach in the robotics software engineering. They actually teach the localization, perception, navigation that we discussed in one of the sessions, and they also teach about the ROS basics. In the self-driving cars, they teach about the different components of self-driving cars, which are perception, control, path planning, localization, and so on. And for each concept that they have, they usually have a project associated with it as well. So it's a really good thing if you would do. You can also apply for a scholarship as well, since you would be a student. They usually give student scholarships as well. So yeah, you can do if you want, just a bit of money spending thing that you would have to do. These courses are really good actually. Okay, so no more questions. I'll just stop the recording.